Hello there, folks. Welcome to this video of me doing out the solutions to the calculus assignment that I put up for you. Now, I made an error there with question 4, so we look at that in class. I didn't put the complete question up. So we're just going to look at these ones here, and I said this is just good practice for calculus. So you're given this question here: the function f is defined on or by or to or x to x squared minus 14x plus 3. Show that dy dx equals to 0 when x is equal to 7. So to do that, you get dy dx. So dy dx in this case will be equal to 2x minus 14. And when x is equal to 7, 2 times 7 minus 14 is equal to 0. Evaluate dy dx when x is equal to 6.9. So that would be 2 times 6.9 minus 14, which will be equal to minus 0.2. Evaluate dy dx when x is equal to 7.1. 7.1, sorry, made a mistake there. And minus 14, and that's going to be equal to 0.2. So hence explain why x is minimized when x is equal to minus 7. So the reason that's minimized is because when x is 6.9, so if you imagine, so this is your x-axis. So at 6.9, so say this is 7. So it's 6.9 and 7.1. So here the slope is negative. Here it's 0, positive. So if you imagine, look, it's negative until it gets to here, and then it's positive, so it has to be a minimum. So it's a negative slope as it approaches 7, and then it's a positive slope as it comes out of 7. So therefore it goes from negative to positive, hence it has to be a minimum. So that's what that question there was asking for. Okay, again, it's a good example of increasing and decreasing functions and how they work. Okay, the next question I gave you was, this function is defined by x cubed minus 108x. Show that dy dx is equal to 0 when x is plus or minus 6. So you start off and you get dy dx, and that's equal to 3x squared minus 108. So when x is plus 6, 3 times 6 squared minus 108 is equal to 0. 3 times minus 6 squared minus 108 is equal to 0. That's all there is to that. Now, by considering the sign of dy dx for two values of x, one less than minus 6 and one greater than minus 6. Okay, so at a value less than minus 6, you could pick minus 5. So if you were to do 3 times minus 5 minus 108, that's going to be equal to minus 33. And 1 greater than minus 6. Okay, so 1 greater than minus 6, you could pick minus 4. Okay, so you'd have 3 times minus 4 squared minus 108, and that's going to be equal to, so 1648, so it's going to be minus 60. Okay, now, so by considering the sign of dy dx for two values of x, one less than minus 6, sorry, that should be less than minus 6, that should be minus 7. So let's do this again. It's important. So again, made a mistake there, but I spotted my error because it was minus 33 minus 60. You can't have two negative slopes. So again, if it's less than minus 6, it's going to be minus 7. So that's what I should have done to start with. 3 times minus 7 squared minus 108. And that's going to be equal to 3 times 49, which is 147, minus 108, which is 39. And the sign is important, it's plus. And then if I did 3 times minus 5 squared minus 108, that's equal to minus 33. Now, so therefore, as we approach, so minus 6, we'd say minus 6 is here. So as it approaches here, the slope is positive, hits minus 6 where it's 0, and then comes down. So therefore, look at the shape, positive, negative slope, so it has to be the maximum point. And then it says, similarly show that x is equal to 6 gives a local minimum value of the function. And you have to remember, because this is a cubic function, okay, so if you look at this and see this is a cubic function, minus 108x, it's done like this. So we said, so it was minus 6, that was a maximum, so it's going to be like this. That's the shape of the graph. And to show that that's a minimum, you pick 5 and 7. So 3 times 5 squared minus 108 minus 33. And 3 times 7 squared minus 108 is equal to plus 38. Same as with the last time, only this time you're going from a negative slope into a positive slope. So it's a minimum point. That's how we do that one there. Okay. Now this one here, all this is a manipulation formula. That's all you're doing with this one here. So now be careful here when it says a total surface area, because a lot of people will look at their tables book and see that the surface area of the cylinder is equal to 2 pi r h. But the total surface area is 2 pi r h plus the top and bottom of the cylinder. So it's going to be equal to plus 2 pi r plus 2 pi r. Because that's the, plus pi r squared, the area, not circumference. So it's the area formula. So it's plus pi r squared plus pi r squared. So that's equal to 2 pi r h plus 2 pi r squared, which is 2 pi r. Now, that can be written as, let that equal to 108. 108 pi. Now, what you can do here is as follows. You can do, take pi, cancels. Okay? Now what I can say is that 2rh is equal to 108 minus 2r squared. And h then is equal to 108 minus 2r squared divided by 2r. So that's what you do, that's that formula there. So I've shown that that's equal to that. And again, just look, so the total surface area is that plus the top and bottom. The area of each of them would be pi r squared. When you add them together, pi r squared plus pi r squared is 2 pi r squared. The pi's cancel, and now you want to just get h on its own. So how do I do that? I bring 2r squared to the other side, subtract it. So that's manipulation formula, which we've done. So you divide by 2r, and that gets you that there. Okay, now you have to find the volume. Okay, so the volume, show that the volume is given by this here. So again, the volume of a cylinder is equal to, and it's in your tables book, and it's pi r squared h. Now we know that h is equal to that. So volume is equal to pi r squared times 108 minus 2r squared divided by 2r. That square will cancel with that over there. So now what you have here is 108 pi minus 2 pi r squared, or cubed, sorry, multiply by the r divided by 2, and that gets me 54 pi minus pi r cubed, which is what you want here. Okay, the next part of this question then was, so again, I'll just run through that again just to make sure that we understand that. Right. Again, so that's my volume. So instead of h, I'm going to put in this here. And then I multiply it out. The r here, r squared, that's r times r, cancels with this r here. Multiply it out 100 times, and that should be pi r. So you multiply it by pi r. So 2 pi r cubed, and then divide it by 2. And that gets you what you want here. Okay, so there was an error in there. I forgot to multiply by the r here, so you can see that. But you always find these errors when you go back over it. And that's a good thing to be able to do. Now, and then it says find the value of R that maximizes the volume of the cylinder. So the maximum value is going to be when the derivative is equal to 0. So if I have volume is equal to 54 pi r minus pi r cubed, well, dV dr will just be equal to 54 pi minus 3 pi r squared. So you let that equal to 0. And this is just your algebra. So 3 pi r squared equal to 54 pi. And then what you're going to have is pi's will cancel. R squared will equal to 18. So R will equal to the square root of 18, which can be written as 3 root 2. Okay, so find the value of R that maximizes the volume of the cylinder. So when the radius is 3 root 2. And then it says find the maximum volume. So what you do is you put 3 root 2 into that formula there, and that allows you to get that answer. And again, in a leaving cert, don't worry. If you've shown enough of an aptitude, it's not about working out the question. That's a calculation. Pop that into your calculator. That's all it does there. Okay. And the last question we had then on this assignment was this one here. So a pebble is dropped into still water and circular ripples spread out from the point of entry. The radius of the circle is increased at a rate of 10 centimetres to -1. Now, I always tell straight away, I look at this and I see the following. I know that that's equal to the RDT. So I'd always just in my head mark that the RDT is equal to 10. Now part 1 you're asked, if R is the radius, write in the area of a circle. So the area of a circle, really this is all you're asked. The area of a circle is pi R squared. The ADR, you differentiate it. And that's equal to 2 pi R. The RDT, so we spotted that from the start, that the RDT is equal to 10. Explain why the ADT is equal to the ADR times the RDT. And the reason that is because when you multiply these out, the DRs will cancel and you're left with the ADT. So it says find the rate at which the area R is 25, so that's the ADT. So for the last part, we can say that the ADT is equal to 2 pi R times 10, and it says when R is 25, so that's equal to 20 pi times 25, which is 500 pi centimetres seconds minus 1. That's all there is to that. Okay, so I hope he's gone all right with that assignment. If you have any queries on that, please email me. You know my email address. It's robk.mathsplanations@gmail.com. And any comments or anything at all you notice with that, let me know. Thanks, guys.